The universe had a beginning. 13.8 billion years ago, everything that exists burst out of a single point. But here is the question. Almost no one asks. If it began, then one day it must also end. So how does the story of everything actually finish? Tonight, we are going to travel further into the future than you have ever imagined. Not thousands of years, not billions, but numbers so vast they make the current age of the universe look like the very first instant of time. Right now we live in the golden age of the cosmos. Astronomers call it the stelliferous era, the age of stars. The sky is full of them, being born in glowing nurseries like this one. But this golden age is already fading. The universe is running out of the gas it needs to make new stars. 90% of all the stars that will ever exist have already been born. The lights are slowly going out. To understand the end, we first have to watch a star die. And the death of a star is one of the most beautiful things in all of nature. In about 5 billion years, our own sun will run out of fuel. It will swell into a red giant, hundreds of times larger, and it will boil away the oceans and swallow the earth whole. Then it will gently blow its outer layers off into space, creating a glowing shell called a planetary nebula. What is left behind is a hot, dead ember called a white dwarf, an Earth-sized diamond slowly cooling forever. This is the fate of most stars, but some are far more stubborn. Small, cool stars, called red dwarfs, burn their fuel so slowly that they can keep shining, not for billions of years, but for tens of trillions. And smaller still are the brown dwarfs, failed stars that never quite caught fire, glowing only with a faint leftover warmth. When the universe finally goes dark, these dim embers may be among the very last warm things left anywhere. But even they cannot last forever. One by one, across trillions of years, every furnace in the sky burns through the last of its fuel. The rate of new stars, already collapsing, slows to a trickle, and then to nothing. So let us start the clock and watch the lights go out one by one across a timeline so long it barely fits in your imagination. 100 trillion years from now, the very last star will flicker and die. For the first time since the beginning, the universe goes dark. There will be no more sunrises anywhere ever again. This begins the degenerate era. The universe becomes a graveyard filled with the cold corpses of stars. White dwarfs fade to black. Neutron stars go silent. And drifting between them, frozen planets in absolute darkness. With no stars left to warm them, worlds freeze solid and drift free, torn loose from their orbits, wandering forever. The temperature everywhere in the cosmos falls, creeping toward absolute zero. And on truly staggering timescales, matter itself may begin to betray us. Some theories predict that the protons inside every atom will slowly decay, causing ordinary matter, planets, dead stars, everything, to quietly crumble into nothing. Robbed of their protons, the white dwarfs dim from white to red to black. Cold, dark spheres called black dwarfs. Invisible tombstones marking the places where stars used to shine. But even in this darkness, the most powerful objects in existence still remain. The black holes. And in the almost infinite time that follows, they will come to rule everything. For an unimaginable stretch of time, black holes are the last great structures in the cosmos, some of them billions of times heavier than the sun, sitting alone in an endless, empty dark. For a time, The black holes even grow. They drift through the blackness, swallowing the last dead stars, the last frozen planets, the last scraps of matter, until they hold almost everything that still exists. But here is the strangest twist of all. Black holes are not truly forever. Thanks to a whisper of quantum physics discovered by Stephen Hawking, black holes very, very slowly leak their energy away. They evaporate. It is agonizingly slow. A large black hole takes a number of years to evaporate. That is longer than you can write down, a 1 followed by 100 zeros. But eventually, even they blink out of existence, one final flash of light in the dark. And so the greatest objects the universe ever made die the loneliest deaths of all. Not with a roar, but with a whisper. A slow leak of light over a span of time so long that the entire history of the universe so far would be less than a single heartbeat beside it. And when the last black hole dies, the universe reaches its most likely ending. Scientists call it the heat death, or, more poetically, the big freeze. Everything that ever existed has decayed into a thin, cold soup of particles, spread evenly across an endlessly expanding void. No stars, no structure, no heat, no difference between one place and the next. Just eternal, featureless dark. To understand why this is the fate that awaits us, you have to understand one ruthless law: entropy. Everything in the universe naturally slides from order toward disorder, from hot to cold, from structure to sameness, and that arrow only ever points one way. In this universe, nothing can ever happen again. No event, no motion, no thought. Time itself becomes meaningless because nothing ever changes. This is not a bang. It is the quietest possible ending. A universe that simply falls asleep forever. That is the most likely ending. But it is not the only one. Because everything depends on a mysterious force we barely understand. Dark energy. The invisible thing pushing the universe apart, faster and faster. If dark energy stays constant, we get the slow freeze. But what if it gets stronger over time? Then we get a far more violent ending. The Big Rip. In this scenario, the expansion of space accelerates until it becomes unstoppable. First, it tears the galaxy clusters apart. Then it rips individual galaxies to shreds. Then solar systems. Then planets. And in the final seconds, space expands so violently that it tears apart individual atoms, and finally rips the very fabric of reality itself. The universe does not fade away. It is torn to pieces. There is a third possibility, and it runs the whole story in reverse. What if, one day, the expansion stops and gravity wins? Everything that flew apart in the Big Bang would begin to fall back together. Galaxies would rush toward each other. The sky would turn white hot. And everything, all the matter in existence, would collapse back into a single, infinitely dense point. The Big Crunch. A universe that ends exactly the way it began. And some physicists wonder, if it can crunch down to a point, could it bounce and explode outward again? A new Big Bang. A brand new universe, rising from the ashes of ours, over and over, forever. And there is one final possibility, and it is the darkest of them all. Our universe may not be truly stable. It may only be resting in a false calm, like a ball balanced on the side of a hill. If that false calm ever broke, anywhere, it would create a bubble of true vacuum, expanding outward at the speed of light, rewriting the laws of physics inside it. we would never see it coming. It could, in theory, already be racing toward us right now. The freeze, the rip, the crunch. We do not yet know which ending is waiting for us, but all of them lie unimaginably far in the future, long after the last human, the last star, and the last light. Which brings us back to something strangely comforting. We exist in the brief, brilliant morning of the universe, while the stars are still shining and the sky is still full of light. Of all the eras that will ever be, we live in the one where anything is possible. The end is coming. It always was. But it is trillions upon trillions of years away, and we are here now, awake, to witness the universe at its most alive. So make it count and get spaced out.